Okay, everyone, let's start the class. Good evening, everyone. Let just give me 1 second. I just have to check something and then we can start the class. I'm just finding the slides. Just 1 second. Yes. Okay. Okay, fine. Fine. I got the slides. So let me share my screen. Okay. Hope my screen is visible and I'm audible. Please let me know if everything is okay. Am I audible? Is the screen visible? Okay, good. Okay, so welcome everyone. Hello, good evening. So welcome to the last session that we're going to have in this Joy of Computing using Python course. This is a 12-week course, and we have finally reached the final week problem solving session. So as you are aware, the problem solving sessions have been held for last 12 weeks concurrent to your course, so that you can have an idea of, get some practice of how to solve problems, how to write programs, so that you are better equipped to solve your assignment and programming questions. And I hope that these have actually been very useful to you. I at least hope that every week during this 2 hours, you have had some time to actually sit at your laptop and do the programs yourself, which you may not have had time to do just watching the recorded lectures. So the idea is that you have this very good resource of recorded lectures, but these are extra sessions to supplement that through some live interactions. And I know that some of you have been interacting throughout all the 12 weeks. Thanks for that. Of course, those of you who are not able to join, I hope you have been able to catch up through the slides and the YouTube videos as well. So just one final time, this is the link in my website where I maintain all the links to, the slides and the YouTube videos. I'll just paste it in the chat. So if you go to this website, you will find that, for example, you can see all the meeting link. You can find the YouTube playlist where the different files, video recordings of the last few weeks have been put, and then also the slides of the sessions are given here. Along with the slides, I've also uploaded all the programs that we've been discussing all the past weeks. So again, I hope that this has actually been a very useful resource for you and you have found it. Okay, so we've reached the end of the course, so that's why all these things. Again, this is my email ID. By now, you know that I am at ISC. So again, feel free to mail me if you have any doubts relating to Python. I unfortunately won't be able to help you with some logistic things about the course or the exam because I'm not at all involved in that. But relating to Python or any other queries that you have, please feel free to write to me. I try to respond as much as I can. So yeah, I'll be happy to take any emails even after the class. Okay. Anyway, so in this last session, we are finally reached the end of the course. This week, again, you are, as in the second half of the course has fully been focused on more and more specialized applications of Python. Since in the beginning of the course, you had already learned about the data types and containers of various kinds that you can use in Python. And the second half of the course is to use more and more specialized libraries and modules which are available in Python for more and more specialized applications. This is for two things: to give you an idea of more complex things that you can do with Python, which is a fairly simple language, but you can do a lot with Python. So to highlight that flexibility. Apart from that, it also shows you about the vast diversity that exists in terms of the libraries and modules that exist in Python. So just to remind you that Python is an open source language, and as a result, whatever um, yeah, it's a open source language. So as a result, whatever application you can think of, it's almost guaranteed that someone would have written a library, that composes all the functions that are required to carry out that task. So as I keep saying, I'm an astrophysicist, and there are multiple astrophysical functions that we do using Python. Many of the most common ones are put in this library called AstroPy. If you watch the YouTuber Three Blue One Brown, for example, the animations that he does in his videos, he writes using this Python library called Manim, which is math animation, which he has written himself. So the advantage of having an open source, easy to modify, free to modify software like Python or language like Python is that people can contribute to it as they see fit. Okay, so yeah, again, we make sure that through this course, especially in the second half, we have tried to look at all these diverse libraries to some extent, but we have not even scratched the surface. So I hope that you will continue to explore these interesting avenues, and particularly those that are relevant for your particular interests or fields, you can follow up on. So yeah, in this week's lectures, particularly we looked at the page rank algorithm for Google searches and the collage conjecture. Of course, I show this slide in every before I move to every session, and this is really important, especially in the last class, because now you are at some level you are bona fide programmers and you will be going out and writing your own code. So please keep these rules in mind. Please write good code. Please write readable code. Please write code that is not a whole mystery that people have to decode, but actually nice and readable with proper comments and spacing and all documentation involved. Again, you will be appreciated for such things. So PageRank is basically an algorithm by Google that determines how pages are ranked in the World Wide Web. So basically, you know that if I search in Google, I can instantly get millions of billions of results. And so how does Google decide which are the more relevant links that should show you on, say, the first page? Because to be honest, most people will not click to second page of Google, right? They won't even go past, say, the first five links. And nowadays, because the AI summary is there, I doubt that people even go past the AI summary. So, in all these cases, what does Google use to actually determine that, okay, this link is better than this link is better than this link? So the way that it does is by looking at how many pages actually link to that page, and then assigns a value to the page based on how many pages link to that page. So for example, something like Wikipedia is cited all across the web, right? Many people use Wikipedia as a source for many other things. And as a result, you will see Wikipedia links being quite high up in your Google's link thing. So this is page ranking, where literally we are ranking pages based on how popular they are in terms of being cited by other links. So this is how page rank works. You can see an illustration here. You can see that the page A is linked back to by many other pages as well, and this gives us an idea of how popular it is in relation to other pages. And this is how Google actually determines what its page rank should be. This is a very simplified view. There is more complexity that can go into these algorithms, and I'm sure that Google has, only made it more complex as time has gone on. But this is the most basic way to understand how pages are linked in Google. After that, we also have the Collatz conjecture that was discussed. This is a very interesting mathematics conjecture. Conjecture is basically a problem that doesn't have a proof, and you can see that this is one of the unsolved problem in mathematics. This is from Wikipedia that people say. So the Collatz conjecture says that it's a conjecture which says that this kind of sequence where we just multiply by 3 and add 1 to a sequence, depending on if it's an odd number or even number, eventually all numbers will give the number 1 when this process is repeated enough times. And so far it looks like most of the numbers give 1, but it has not yet been true for all numbers. So remember that in mathematics, even one number not obeying this will be enough to disprove it. But so far, even very high, arbitrarily high numbers have not given such a falsification. So we are still not sure if this is true for all numbers, or if it just holds to high degree to high number of numbers, right? There's a very nice Veritasium video on this that I've linked, and you can watch in your own time. So anyway, you found out about these two interesting projects in Python. So again, you can see that even in the single week's lectures, what is the diversity of problems that you encountered, where, you on one hand, you're looking at something that is very fundamental and something that we encounter every day. On the other hand, you're looking at some very abstract piece of mathematics, which we may not be encountering at all. So this is the power or diversity that Python offers us. Oh, yes. Sorry, sorry. So yeah, this is the video. Please watch it because it's a very nice video and I found it very useful when learning for this class. Okay, so now let's move to the question. So again, as usual, I will show the question. Please give your answer in the chat about it, and we can do this. So again, this is the very last class. So all of you, please participate. That would be nice. This is the last chance to participate in this thing. So that's why. Okay, so the first question, it's about graphs. We kind of discussed graphs last week also. So which of the fall or last week or the week before, I don't remember now, but yeah, we have recently also discussed graphs. So which of the following graphs is generated by the given Python code using the network X module? So we are using this library called network X, which is used for these graphs, directed graphs and other things. So some code is given. So the question is that what kind of thing will it generate? Please put your answers in the chat. Oh, sorry, did I mute? Yeah, I can see that few people are giving C. C, C. Okay, okay, good. So most of you have given the correct answer, which is C. So again, you can see it from the code itself. We have these nodes, we have 5 nodes, 1, 2, 3, 4, 5. You can see that there should be a connection from 1 to 2, 2 to 3, 3 to 4, 4 to 5, and then 5 back to 1. And that is what is given here actually. So 1, 2, 2, 3, 3, 4, 4, 5. 5, 1, you will see that the other graphs, they don't have all of the connections that is mentioned here, and that is why they are not the correct answer. So good, I think most of you have given the correct answer in this case. Okay, fine, good. So let's go to the next question. In network X, which function is used to return the degree of a specific node? Okay, someone says A. Any other answers in the chat? Okay, C. Okay, I can see many people saying A. Majority answer seems to be A with few B. I'll just give one more second if people are still answering. Okay, let's go to the answer. So the answer is A, which I think majority of people gave. So again, remember that whenever you have any sort of library, you can, sorry, this is something else. So remember that whenever you have any kind of library in Python, you can always go and find its documentation. This we have also learned, and this is a good skill to have. Whenever you come across a library in Python, just search for its documentation and you will find a page like this where basically all the functions and all the things that you need to know about it is given in one easy page to refer to. So it's always good to, when you're getting familiar with Python and using different libraries, to always go to this kind of page and see. So here you want to see what is the function to return the degree of a specific node, not just the number of nodes. So we can check here. So here this returns the number of nodes. Let's see if degree, where is degree? So you can see that g dot degree returns a degree view of a single node, and that's exactly what we also got, right? So you can see that here, you can see it gives you what is the format and whatever what it tells you to how it is used. So you can see some examples of how it's used and also that. So always, it's a good idea to always have this habit. I know nowadays things are more readily available with AI and stuff like that, but still have the habit of going through the actual documentation, because if you search for a specific function, you will only learn about that function. But if you search broadly, then you have an opportunity to also learn about the other functions which are there in the library which are related. So it's always a good idea to have just a quick look into the documentation. This is the next question. Observe the following graph generated using network X. How many edges does this graph contain? Okay, someone says 6A. Okay, I can see two people saying B. Okay, one more person says B. One more person says B. B. Okay, I think we can go to the answer. So answer is B. So most of you have answered B. Good. So here again, the edges means which connect two nodes. So here you can see that 1, 2, 3, 4, 5, and then we have one edge here 6 and one edge here 7. So there are totally 7 edges in this graph. So I hope this is clear to everyone. Please stop me if anyone has any doubts, okay? I'm just assuming that you understand these questions. So what does nx dot cycle graph of 4 generate? Okay, someone says B, D. Okay, can see many people saying B. Maybe we can go to the answer. Is anyone else going to answer? I don't think so. So the answer is B. As the name suggests, nx.cycle graph generates a cycle graph in its closed loop. So what is a cycle graph? Basically, if you just look at Google Images, it will give you an idea. Cycle graph is basically when you have this closed graph. That is, it's like a cyclical thing where it finally goes back to the starting. You can see that it goes back to the cycle starting. So, and that is what exactly Network X does with the cycle graph command. Okay, next question. Observe the following graph generated using Network X. What type of graph is this? Okay, someone says B, 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 B. Okay. Okay, I can see that a lot of people have instantly answered B. Maybe you can go to the answer. The answer is indeed a barbell graph. You can guess why it's called that. This looks like a barbell or a dumbbell as it's called. So again, if you search barbell graph on Google, you can find pictures of it and you can see that it is basically having two cycle graphs which are connected kind of thing. That is what a barbell graph is. Okay, so that is what a barbell graph is. Nice, very good. Okay, let's go to the 1 second. Right, let's go to the next question. Okay, so there's a piece of code. The question is, what will be the output of the following code? Okay, someone says A. Just give me a second. Okay, okay, I can see that most of you are saying A. Someone says C. A again. Any other answers? Okay, let's go to the answer. So I think majority of you said A. The correct answer is A. So the number of nodes we can just see right away is 4 because there's 1, 2, 3, and 4. The number of edges is just the connection between two nodes. And here you can see that 1 and 2 have a connection, 2 and 3 have a connection, 3 and 4 have a connection, and 4 and 1 have a connection. So there are 4 edges and 4 nodes. So that's why the answer is A. And this is just giving us the length of both. Next question. So this is based on collatz, which we just discussed at the beginning. What will be the output of the following code? Okay. For, someone says A. Any other answers? A, someone says B. Someone else says B. One more B. Others, please answer. Okay. And see one more B and someone says D. Okay, I think all four options are there in the options A, B, C, and D. Though the majority answer seems to be B. Maybe you can move to the answer. So the answer is actually B. So good job to those of you who did it. So again, the Collat's conjecture is based on the fact that how many steps does it take when applying this process to get a number to 1, right? So we need to see how many steps it takes to take 7 to 1. So obviously 7 is an odd number. So initially we get 7 to be 3 into 7, 21 plus 1, 22. And then 22 becomes 11, then 11 has to become 34, then it becomes 17, and so on. So there are actually 16 steps. Let me see if there's some place where we can easily visualize this, or else we can write the code itself. Okay, generate the Collat sequence. So nice. So let's 7. No, I don't want 7. Let's just see. So you can see that it takes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 steps to reach to the number 1. And that's exactly what is given here. We don't count the first step, of course. We count from this from the next number onwards. That's how it is in the loop. So you can see that it takes 16 steps, and that's exactly why the number is 60. Okay. So again, it's 3x plus 1, then divided by 2, then 3x plus 1 divided by 2, etc., etc. It keeps on going on. Okay, I hope this is clear to everyone. This is a maths thing. Just please check the answer yourself if you are not convinced. Okay, next question. Okay, so look at the code carefully. It looks kind of like the Collat's code. What will be the first 10 numbers generated starting from n is equal to 7? So this is a question. Please put your answers in the chat again. Okay, I can see that people are answering with A. Many of you are answering A. Any other answers in the chat? Yeah, maybe we can go to the answer. So the answer is actually A. So good job to everyone who answered. So here you can see that looks like the Collatz conjecture, but it's 5x plus 1 instead of 3x plus 1. So all we need to know is just we need to go through the sequence. Here it's not having a stopping condition of stopping at 1 or anything. It just needs to generate 10 elements. You can see that it continues until the length of the sequence is less than 10. And in the question also we are asked to look at the first 10 elements. So obviously 7 is an odd number, so it will go to the else part of the loop. So 7 into 5, 35 plus 1 is 36. Then in the next sequence, 36 is an even number, so we'll just divide by 2 to get 18. Then 18 is again an even number, so we'll divide by 2 to get 9. Then after 9 is an odd number, so 9 into 5 is 45 plus 1 is 46, and so on. So you can see that up till this point, both these options are the same, but the next element being 46 is only true in this option. So this is the correct option. I leave it as exercise to you guys to check if the remaining sequence is also correct, whereas whether after 46 you really get 23 and so on. But just based on elimination, we know that this has to be the correct answer. But yeah, please verify if the rest of the sequence is also correct. Okay? Any doubts in this so far? Okay, if not, let's go to the next question. Which technique is used in the page rank algorithm to determine the rank of a web page? Okay, I can see people saying B and C. Both B and C seem to be there. Okay. So maybe we can go to the answer. The answer is actually C. I think slightly more of you had chosen C. So here what you do is, as I said, that the simple idea behind random walk is to see how many pages link to a particular page, right? How many, for example, I gave the example of Wikipedia, many pages will be linking to Wikipedia as a source, for example, or a reference. So the idea is that you do a random walk, which means that you start at some point and then you randomly try to reach one from point A to point B on a graph. And you check what is the probability that you reach a particular, you pass through a particular node, say, and that node could be a web page. So if a web page is very closely connected, that means a lot of edges linked to it, right? Or that node has a large degree if we use the graph theory language. So that's how the page rank is used, in the sense that you do a random walk and you check what is the chance or the probability that actually a particular node is landed on or not landed on. And this is how you decide how the rank of a web page is. Is this clear to everyone? So again, as I said, the very simplistic idea I gave you, this is how it's actually done in real time. Is this clear to everyone? Okay, good. Next question. In the PageRank algorithm, what happens when pages receive multiple inbound links from highly ranked pages? So I think this is a self-evident question. Please, all of you answer. Okay, someone says B, B, B. Okay, I think most of you have said B. Correct. Its rank improves. So as I said in the beginning, the page rank algorithm description I gave you was the most simplistic view, but it can be made more complex. One of the ways in which it can be made more complex is like this, where it not only matters what kind of page, how many pages are linking, but what kind of pages are linking. So if a very highly ranked page is linking to your page, that shows that your page is more trustworthy. If Wikipedia itself is citing you as a source, that shows that at some level you are a trustworthy source compared to if some random page is linking to you. So that is how the trustworthiness or the rank of a source can be further modeled using PageRank algorithm. Okay, that brings us to the end of our MCQ. So now let's go to the programming assignments. So this is the last bunch of programs we'll be doing together in this class. So I have a few programs today of different kinds. Let's try to cover them as much as we can. Remember, if I am not able to cover some program in time, I always share the answers in the Google Drive. So make sure you are going and checking it. But again, I would encourage you to not look at the answers at first, but rather try it yourself, give it a try, and if you have any doubts, to then refer to the Google Drive if you need it at all. Okay, even if you understand the solution, and if you have already looked at the solution also, I would highly encourage you to still try to at least reproduce that solution based on what you understood. Unless you sit and start writing the code, no, all these doubts about coding and programming will not come in your head. So that's how you need to do it. Okay, so let's go to the first question. Given a sorted list nums in non-decreasing order, so it's in an increasing order sorted list where every element appears twice except for one unique element, find and return the single number. Okay, so it's 6:42. I'll give you maybe 10 minutes to discuss this. At 6:55, let's discuss this question. Okay, and please, again, all of you, it's the last class, last bunch of programs. All of you, please try this out, and at 6:55, we'll share the solutions together. Until then, please don't share your solutions if you get it before time, so that everyone gets a chance to try it out. Okay. So I'll give you till 6:55. Please try the question out. I hope the question is clear to you. It's a very simple question. There's an example also on screen. Basically, I have a list which has multiple repeated numbers except one number which appears only once. You have to identify that one number. Okay, does anyone have the answer to this question? Does anyone have the answer? Did anyone solve the program? Okay, good. You can share your answers in the chat. I can see someone has already shared. Very nice. So you've just used the count function of nums. Very nice. Okay, nice. So multiple of you have done the question. Very good. I'll also share my solution for completeness. Great. So here you can see that, um, yeah, here we are basically just checking for the number by just checking each pair at a time. So many of you have used the count function, which is fine. So here we are just checking pairs together at a time. If any of the numbers do not have a pair, then that just gives me the left. So you can see that it just returns the index where this kind of condition is not met. That means that the pair is not met, right? So here you're just each time you're taking the middle element and then checking the pairs whether they are consistent or not. So you can see that we start with 0 comma lens of left and right, and then at para we are checking everything. Okay, so this is how the program is done here, and whichever number does not have a pair is what is giving the base. Yeah, so the answer is 4 because, oh, I'm so sorry. Yeah, the answer is 4 because 4 is the only one which doesn't have a pair. So even in my code, you can see that you are checking if each number has a pair, and whichever index does not have a pair associated with it, that is the one that comes. So suppose if I run this and I run the same thing, like 1, 1, sorry, enter it here, 1, 1, 2, 2, 3, 4, 4, 5, 5. You can see that the number is 3 because 3 does not come in a pair. So that is what is given in the question, right? So similarly, if I give 2, then 3, 3, 4, 4, 5, 5, 6, 6. Yeah, so you can see that 2 comes. So pair is for 2. That's true because the question told us it's for 2. So that's why here I'm checking it as pairs. But yeah, if the list has 3 of the same number and if only one number appears once, then we have to do it in a slightly different way. Correct. So that's how you do it. So any other doubts in this part, or we can go to the next program? Okay, if no questions, then we can just go to the next question then. Okay, so this is the next question. You are given a string S consisting only of lowercase English letters. Your task is to return a list of unique characters from the string sorted in descending order based on their frequency of occurrence. If two or more characters have the same frequency, they should be sorted in alphabetical order. So this is the idea where you have a string S which only has lowercase letters and you get the string a list of unique characters. So if you want some examples, for example, if the string is tree, then you should get E, R and T. So basically E comes twice, so it comes first. Then R and T come the same frequency, that is it comes once and T also comes once, but R comes before T in the alphabet, so that's why R comes first then T. In example 2, you can again see some random string of letters B, B, C, C, D, 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 A, or something. So the output is A, B, C, D. Why? Because A appears thrice, B appears twice, C appears twice, and D appears twice. So A comes first. Then among B and C and D, you can see that since they have the same frequency, they are sorted alphabetically. Is this clear to everyone, the question? Is the question clear to everyone? Question clear. Okay, I guess so. If you have any doubt, let me know. Otherwise, you can try this question. I'll again give you 10 minutes. Sorry. And you can try, we can discuss the answer at 7:10. Okay. So again, try it out. Let's discuss the answer at 7:10. This is also not a very difficult program. So I want everyone to try it out. Okay. Okay, someone says they don't understand the question. Okay, so basically, I can try to explain this again using the string. So basically, you have a string of letters and you have to sort, you have to give an output based on each character of the string, sorted in descending order based on how many times it happens. Okay, so that's called the frequency of the character. So, for example, in the word tree, T comes one time, R comes one time, and the letter E comes two times. So obviously the frequency is greatest for E. So in the output, E should be first. Now, if two letters have the same frequency, like T and R both have the same frequency, they both appear once in the word. In that case, the output should have the letters in their alphabetical order. So you can see that the output is ERT because E comes twice, R comes once, T comes once, and because these two appear once each, when we are displaying them, we display them in the alphabetical order. So R comes before T in the alphabet. This is even more clear if you look at the next example. So you have this random string of B, B, C, C, D, D, A, A, A. Here you can see that the frequency of each character is given. So A appears three times, B appears two times, C appears two times, and D appears two times. So you can see that A should come first, of course, in the output. Among B and C and D, because they all appear twice, they have to just come in the alphabetical sequence. So it just comes as A, B, C, D. Okay. Is this clear now? Do you understand the question now? Whoever asked. Is the question clear? Any doubts? Yeah, I will discuss the answer, but first you please try writing the program. I will discuss the answer at 7:10. I am giving you a chance to write the answer. Try writing the code yourself. This is the last week of the course. Yes, you have to sort and descend in alpha in based on the descending frequency only. The alphabetical case only comes if two characters have the same frequency. So again, look at the question, right? Your task is to return list of unique characters from the string, sorted in descending order based on their frequency of occurrence. Now, if two or more characters have the same frequency, then those characters should be sorted in alphabetical order. Is it clear now? Okay, good. Good, good, good. Okay. As I said, I'll give you till 7:10. Please, all of you try. If any of you have got the solution, we can discuss at 7:10. All of you, please try again. We are in week 12. We are in the final week of your course, right? By now, such programs you should be able to write easily. This is not very difficult. Okay, does anyone have the answer to the question? If you do, please share in the chat. Yeah, I can see one answer in the chat. But here, where is the count taken care of? Okay, I can see scene.add. Okay. As long as your answers work, you're getting the correct answer and you understand the logic, it's fine. I may not immediately be able to understand your logic. So please try with these examples that are given, that if it is given the correct answer or not. Okay, good. So someone else has also given the question. I've sorted based on the frequency. Okay, good. Good, 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 good. Okay, okay. So then I will also share my answer now. Few of you have got the answer. So you can see that basically there are four steps. One is we have to count the frequency of each character. Second is we have to create a list of character and frequency pairs. After that, we are sorting the list based on the frequency and then alphabetically. So first, okay, and finally extracting only the characters, because finally we only want the characters. We don't want the frequencies to be displayed. So let's see, step one, how it's done is we are using set. So last week itself, we spoke about sets, which is that, oh, sorry, this is a dictionary. I'm so sorry. So this is a dictionary. You can see that this is a dictionary because I'm describing frequency of character. So basically, I'm sorting it into a key value pair. Here, the key is going to be the character and the value is going to be how many times it appears in the list, right? So here I'm getting the frequency of each character using a dictionary. Okay, so this is a dictionary. Okay. Then I'm creating a list of character frequency pairs. So you can see that basically this is just a list. Now I'm just sorting the list based on frequency and then alphabetically. So just going through the list for each of the values in the list, first checking the frequency with each other. Whether if at all, if either they are less than or they are equal to, but the character is larger than. So here you can see that I either check the frequency, or if they are equal, I have to check the first character. So remember that this is in pairs. So frequency of list of I of 1 gives me the number, and frequency of list of I of 0 gives me the character itself. So the first condition in this if gives me that the frequency is frequency itself. Here the second part of the condition is to check if the frequencies are equal, then compare the character values. Then I have to make sure that the character values are there correctly. So you have to swap the position if any of these conditions hold so that you get the correct order. Then you want to only have the characters in the sorted list. So result is equal to character for character comma count in the frequency list. So then you return the result. Okay, so this is just how it's done. So again, this is a little longer. You guys have done it in a much more efficient way. But because in the question explicitly they had asked for these two conditions, we want to make it more explicit at where these two conditions come in. Of course, Python has a lot of inbuilt things that make all these calculations easier, and many of you have used that in proper ways. So let's see if this works. So let me just put first here. So let's put in tree again. So you can see that ERT. If I put in something like A, B, B, Z, 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 C, D, E, G, G. Okay. So then you can see that Z is appearing the most. So it's first, then A, which appears thrice. A and B appear same number of times. Then C, D, E all come to, sorry, A, B, and G all appear twice. So they are coming in their alphabetical order. Then C, D, and E come in once. They also come in their alphabetical order. Okay. So this is the idea. Any doubts in this answer? Any doubts in this question? Okay, if not, let's move to the next question. Is the next question. Write a Python function subsequence of L1, comma L2 that takes two sorted lists as arguments and returns true if the first list is a subsequence of the second list and returns false otherwise. So when you call a subsequence of a list, it's obtained by dropping some values. So 2, 3, 4, comma 2, 2, 5 are subsequences of 2, 2, 3, 4, 5 because you can see that 2, 3, 4 is present in 2, 2, 3, 4, 5 and 2, 2, 5 is also present in 2, 2, 3, 4, 5, but 2, 4, 4 is not there and 243 is also not there. It has to be in the same order. So that's why subsequence is not there. Okay. Please try this. So again, I'll give you 10 minutes. Let's discuss this at 7:25. Okay. Sorry. I hope you all are, oh, I hope you all are solving. Hope you all are trying. We'll discuss in few minutes. Has anyone already got the answer for this question by any chance? Anyone got the answer for this question? Can share it. Okay. We'll discuss in 5 minutes. Then I'll give you 5 minutes. Okay. Okay, fine. So I can see that there are some answers in the chat. What's the question? How 234 225 sequence 223? No, basically these two are subsequences of this, right? Because 234 comes in this sequence. 2 2 3 4 5. You can see that you have 2 3 4 contained within the sequence. At the same time, 2 2 5 is also within the sequence, right? 2 2 5 is also a subsequence. Whereas 2 4 4 is not present in this sequence. 2 4 3 is not present in this sequence. So that's why those are not valid subsequences. Is this clear? So I can see that someone has already given the answer. So I can also share the answer. But in the meantime, is it clear what I said? Why two double time? Well, because the original sequence has 2 2 3 4 5, right? So when you have 2 2 5 in that order, it's a subsequence. It's just checking whether something is a subsequence with respect to this sequence. That's all. You're not adding numbers. See, this is my big sequence, right? It's like a list. In a list, I can have a sub list, right? If I have some big list of 6 elements, I can take 3 of those elements and form another list. So that's what a subsequence is. In this list of 5 elements, if I just take the middle 3 elements, 2, 3, and 4, I found subsequence of 2, 3, 4. If I take the first 2 elements and the last element, I get 2, 2, 5, which is another subsequence. That's all. Okay, there's nothing about adding or subtracting or anything like that here. Okay. Okay, fine. Let's go to the program itself. Right. So here you can see that what we are going to do is very simple. We are just going to define L1 and L2. We want to check if L1 is a subsequence of L2, right? So we are just going to check if L1 of I is equal to L2 of J. I'm just going to continue going and check if that is actually present or not. Okay. And then we are going to check whether the same elements are there in L1 or not. Okay, that's all what you do. So if I do, for example, 2, 2, 3, 4, 5, 2, 4, 3, then it's false, right? Whereas if I give 2, 2, 3, 4, 5, and then I give 2, 3, 4, then you can see that again it's giving false. Okay, there's some issue. Oh, sorry, I gave it in the reverse order. It checks whether L1 is a subset of L2. I'm so sorry. Sorry. Okay, let's just go this. Yeah, so now you can see that it's true because this sequence is actually contained within the other sequence, and that is why this is actually a true sequence. Okay, so let's look at what the code is doing again. So if you want, we can just print this. So the way to understand what a code is doing, the best way to understand is just to print these things like I, J, L1, and then you can actually see what is happening. Okay. So you can see that goes to the first element because the first element is where, basically I starts from 0, but when it compares 0 and 0, then it just checks where L1 of I is equal to L2 of J, then I plus equal to 1, print I. So, we see that the first element itself is equal, so it is printing I. Then J also plus equal to 1 if we are going to the next element, and then again checking if they are equal. So basically what we are doing is we are checking if where and all we get the equal elements. And then if all the elements are equal, then eventually the count I and the length of L1, they are going to be the same, right? Suppose only 2 of these elements were there. So suppose I'll just remove the print statements because I think they're a little confusing. Suppose I entered something like 1, 2, 3, and here I have 2, 3, 4, 5, 6. Okay. So then this is not a subsequence of that because it will find that these 2 elements are the same, these 2 elements are the same. So your I is going to be 2, but at the same time, 2 is not equal to the total length of the list. So that already tells me that one of the elements is left out, right? So one of the elements is left out means that I am not able to find the sequence, right? So that is why I get a false in the thing. So that's why the true condition is based on whether I is equal to length of L1. I identifies whenever there's a common element between the two lists. And if all the elements of list 1 are present in list 2, then I will simply be the length of L1. So that's why the true condition is based on this. And you can see that we are going in the sequence. So something like this, if I give, for example, 2, 4, 3, and then I give 2, 2, 3, 4, 5, it still gives false. The reason it gives false is because even though all the elements are present in this, they are not present in the sequence. And the sequence is ensured because we are checking in while I is less than L1 and J is less than L2, we are checking in that particular order only. So it has to be in that order, then only I is basically, sorry, what am I doing? This should be I equals. Yeah, I think now it's correct. Yeah. Or if I give true. Okay, so now if you can understand basically what this is doing is this is checking the common elements, but it is also checking if the common elements are there in that order. That's why I don't just give if L1 of 2 is equal to L1 of j. I give it in this order so that if it's 2, 3, 4 in the list also, it should come as 2, 3, 4. It can't just come at 4, 2, 3 or something. It's not just it has to be common, it has to come in the same order. Okay, and then if they are common and if all the conditions are corrected, then how many ever elements are there in L1, each of them will give a positive I. So I will be equal to L1. And that's why the true false condition is based on that. Okay. Is this clear to everyone? Is it clear? Yes, no. Some people are having doubts. That's why I'm asking. Okay, good. Fine. Good. So let's go to the next question. Okay, this looks like a long question, but it's actually very simple. A square metal plate in 2D space is the setup we are going to work with. The spatial extent of the metal plate is given by 0 x comma y x comma y laid between 0 and 5. So you all know how to construct a 2D grid, right? X comma y means it will give you the x position which is in the horizontal axis and y position in the vertical axis. So here this is a 2D grid and the x and y values lie between 0 and 5. So you'll have something like 0 comma 0, 0 comma 1, etc. Then 1 comma 0, 1 comma 1, etc. till 5 comma 5. The temperature at any point xy is given by the following equation. The temperature is measured in Celsius and can be negative. So this is the equation. So there's a microorganism which lives on the surface of the metal plate. It occupies only those points on the plate where both the coordinates are integers. The organism cannot survive in high temperatures and instinctively moves to region of low temperatures that are less than or equal to a threshold temperature T. If such region is not, no such region is found, it can't survive. The terms high and low are used in relative sense and should be compared with respect to threshold. Write a function named survival that accepts the value of t as argument and returns true if the organism can survive on the metal plate and false otherwise. So again, not a very difficult question. It looks long. Simply, we have a grid and we have a function which gives the value of temperature at every point in the grid based on the xy values. Now, there's a microorganism. It can only survive if the temperature is less than or equal to some value, which we are calling the threshold, right? So you should write a function that for a given threshold will tell you whether the organism survives on the metal plate or not. Okay. Any doubts in this question? Sorry. Any doubts in this question? Any doubts? Okay, I'll give you 10 minutes. Let's discuss this at 7:40. Okay, all of you please try the question and then let's discuss at 7:40. Again, looks like a long question, but it's actually a simple question. Okay, please all of you try the question. What was the link for these sessions? Yeah, I'll share that at the end of the class. You mean, I hope you mean the Google link and the YouTube link and other things. I will share the link at the end of the class. Okay, has anyone got the answer for this question? Anybody? Okay, good. Yes, someone has given the answer. Sorry. Very good. Yeah. So that's it. It's a very simple question actually, even though it looks very long. So I can also share my answer in the chat. Sorry, in the question. So basically, this is my function 30x plus x square plus y square minus 3x minus 4y. This is already given in the question. And what I am doing is I am defining survival of t. And for each x and y, if f of x comma y is less than that t, then return true. Otherwise, return false. So what I'm going to do is I'm just going to float an input, enter the threshold temperature, then depending on whether it survives or not, you can do. You can also have a code to visualize the grid of temperature, so you can visually also see if the survival is possible or not. So for example, if I just give the threshold temperature to be 20 degrees Celsius, okay, wait, let me just clear it first. So suppose suppose I give the threshold temperature to be 20, you can see that it's false, because you can see in the grid that this is basically the grid that you will get if you actually calculate for all the points on the grid. So you can see that this is a 6 cross 6 grid, because the each x and y can take 0, 1, 2, 3, 4, 5. So there are 6 values here and 6 values here. So it's a 6 cross 6 36 point grid. You can see that there is no point on the grid which is less than 20 degrees Celsius. So my organism will die. On the other hand, if I give something like 40, you can see that it is true, because there are plenty of points in the grid which have 40 degrees Celsius. So it can go to any of those points and still survive. Similarly, if I give something like 10, it still can't survive, because again, the minimum value on the grid, if you can see, is like I think it's 24 degrees. So in not anything smaller than that, it will not be able to survive. So it's a very simple thing. I have just done the extra step of also visualizing the grid, so that it's easy to see whether it's actually true or false what you have calculated. Okay, is this clear to everyone? It's a very simple question. I think everyone should have got this by now. Any doubts in this? So we have just calculated the function. Then for the survival, we are just checking if that function at every point, and we just put range of 6 because we want 0 to 5. And remember that range will not consider the last value. Just giving the range of 6 will automatically give me 0 to 5. So that is why we choose range of 6. Okay, fine. So let's go to the next question. I have one more question after this, but that I'm not going to go into. Let's take this as the final question of the day, and of course of this class also by then. So please try to solve this question. It's a very simple question again. I'll give you 10 minutes. Write a function standard deviation that accepts a list of x numbers, real numbers x as argument. It should return the standard deviation of the points, which is given by the following formula. Here xi refers to the element x of I in the list, and x bar refers to the arithmetic mean of the list numbers in x. Try to use list comprehension wherever possible. So please try this question. This will be the final question of the day. Please try it out, all of you, and then we can discuss. I'll give you 10 minutes. So this is basically what a standard deviation is. Again, you should be familiar with this from your maths classes. If you have a Gaussian or a bell curve, the standard deviation is how much deviated it is from the center, basically. So please try to solve this question and let's discuss it in 10 minutes. Okay, someone has got the answer. Please share your code also, what you have got. Or if any others have finished, you can also share your answer. This is a very simple question. I think you guys could have done it by now. Okay, very good. It's just to write this formula in a code language. That's all. There's nothing more complicated than that. So you should be able to do this. Any others who have got the solution? Anyone else? Okay, maybe we can discuss the solution. So basically, you can see here that we have, sorry. So let's see, program 5. So you can see, yeah, okay. Good. So you have also done the question. So you can see here that we just have the mean of x, which we are using sum of x. Then sigma, which is the standard deviation, is just we're just going to do x minus mean squared for all x in x divided by n minus 1 and then to whole to the power of 0.5. So I've just used pow. Pow is a function where you put the number, comma, whatever power you want to raise it to. Since it's a square root, I've done this. You can also import math library. In math library, there is a square root function itself also. Okay. Nice. Someone else has also got the solution, although it looks AI generated. I can see the commas and inverted commas. So please try to write your own code. Anyway, so you can just enter. So someone has already given for some particular list. Let's see if our answers match up. So they had given 2, 4, 4, 4, 5, 7, 9. What did I do? Oh, okay, okay. Sorry, I had given this in terms of commas. So I should also give in commas. 2, comma 4, comma 4, comma 4, 5, 7. Is this the list you gave? 2, 4. Oh, I gave 3 fives. Okay, let's try again. 2, 4, 4, 4. 2.14. Yours is 2.138. Yours is, of course, more digits. I've just rounded off to 2 digits. So it works, right? So this is a very simple program that everyone should be, at least this kinds of programs should be very easy to you now that you've gone through this course. Okay, I had one more program, but since the last class, let's not go into it. The last program is about printing Pascal's triangle, which is this figure with the order and taking n as an input. I have the question, so as usual, I will just share it in the Google Drive. So I wanted to formally end the course, so let's leave the last few minutes for that instead of discussing this question. As always, I will share this in the Google Drive, so please all of you go and take a look and try to do it yourself. Always, even if you understand if you think you understand the question, you don't unless you sit and write the code yourself. Okay. Okay, cool. So you have also shared, people are sharing their answers and everything. That's very cool. So let me just move to my last few slides. So thank you for joining so much. So hopefully this course, Now, I have done a small part in this course. The main part is, of course, by your instructor and the other TAs who have actually graded your assignments and given you your lectures and all those other things. So, I hope this was actually a useful course to you. I hope that you have been doing. Just to give you a recap, these are all the different things that you have learned in this course. You can already see what are the very diverse and interesting questions you have learned, from birthday paradox to lie detectors, rock, paper, scissors, ciphers. You learned about this movie games and other kinds of games, tic-tac-toe, snake and ladders, all kinds of games, to even how Google works, right? And throughout this course, you have solved an average of 5 questions in every class, in my problem solving classes. So along with all these programs that you have studied in the class, you have also done 50 plus programs during this set of problem solving lectures. Hopefully those have been useful to you, and of course various other programs in your assignments. So now, if you have kept track of it properly, you have a good repertoire and good collection of programs with you that you can refer to easily with a diverse range of applications, especially in Python. The key takeaways of this course, I would say, is the following. First of all, programming is a tool. Okay, programming is not some magic skill, it's a tool. Like all tools, it's only as useful as the person who's making use of it. So, I always give the same example, which is that, you know, of course, we should not have. Okay, someone has already written the program Pascal triangle question. Good. I hope you wrote that yourself. If so, you are very fast. You're faster than me. Anyway, the point is that programming is a tool. Like all tools, it's only as useful as the person making use of it. I always give the example of printing 1 to 100. The Python can do it even if you give print 1, print 2, print 3, like that. If you give 100 print statements, or if you give a loop, right? Obviously, a loop is more efficient. But that is up to the programmer to know that fact and make use of that fact. The important thing is that this was a Python course, but remember that programming languages may vary by syntax, but programming logic is universal. So tomorrow, if you want to pick up something like C or C++, remember that the logical processes that you have used to deduce the solutions are as important, if not more important, than writing the program itself. It's okay to make mistakes in writing the program, but the important thing is that you are able to arrive at what should be the actual solution in the first place. Python, particularly, is a very good language to start your programming journey with, because Python is a very powerful and well documented language with many interesting modules. So please always be curious and take advantage of the vast web of resources which are available with Python. As I said, whenever you come across a module or a library, go to its documentation page, not just for the functions you use. Just take a 5 minutes to just scroll through the documentation page and see what are the different things you can actually do. Something like NumPy has hundreds of functions, so obviously it may not be possible to remember all of them. And never in programming you should memorize things, by the way. It's always based on logic, right? You should learn how to look up things also. That's equally important in programming, is how to look up things. And if you're able to actually Google and get the answer, it's almost as important as the skill of programming itself. And finally, I've repeated this all 12 classes, but maintain good coding practices and documentation. Give your variables and file names proper names. Don't just keyboard smash ABCD1, ABCD2 like that. Give proper names, give proper documentation. If you do so, your future self will thank you, and people will actually like to read your code. Okay. Remember that this course, being 12 weeks, we have covered a lot of material, but still, this is not even the tip of the iceberg, as people say, when it comes to Python. There's so much more you can do, and so much more that you are yet to do. So please be curious, and I hope that this is the start of all of your journeys towards programming, and you're able to find a lot of, joy, as the course name suggests. You're able to find a lot of joy in computing using Python. And I hope that, you all continue using the skills that you have learned in this course to actually take that forward and apply to whatever field you're in. As I said, I am not a computer scientist, I am an astrophysicist. But as I said many times, I use Python every day in my work. And almost everyone I know, be it an engineer or, someone who's doing research like me, or, even a a writer or something. Everyone needs Python or programming at some level in their work. So please try to be curious and keep this spark going. This course has given you the initial spark. It's up to you to continue this. Don't just learn for your exam or your assignments, but try to keep this going after that also. That being said, all the very best for your exam. I hope these problem solving sessions have actually enabled you to have some practice before your exam, given you some confidence that you can solve problems yourself. And remember that all the links are available to you. So please go back. You can go, and as I said, there are 50 plus programs in these lecture notes alone. Go back. I have shared all the solutions also. I will be sharing for this class also. Go back and see. And if you have any doubts, you can contact me about the programs. I'll just share the links again in the chat. So this is the link that I maintain on my website where you can find all the YouTube videos and the lecture notes for the course. And this is my email ID that you can mail me at if you find any issue in any of the lecture notes. Again, as I'm just repeating, I don't have any handle over your exam or evaluation or mode of exam or anything like that. So if you write to me about that, I will not be able to help you. But if you have any doubt in the lecture notes that I have given you, please feel free to reach out to me. I hope that you guys have a good exam, but again, remember that the point of the course is not the exam. The point of the course is to give you this access to this wonderful world of programming, and that's why the course is also called The Joy of Computing Using Python. So it is actually a joyous exercise. It gives you so much power in the world if you're able to solve problems by yourself using these powerful computational tools. Okay, so happy coding. Remember that if you use Python properly, you can even fly. Okay, thank you so much. Thank you for joining for the last 12 weeks. And I hope that these have been useful to you. And all the very best for your exam. Thank you so much. If anyone has any final comments, you can share now. If not, let us end the class for today and for the rest of the course. Any final comments? Okay. Yeah, you're welcome. Thank you all, everyone. All the very best for your exam. And yeah, I hope we can meet sometime if the time permits. Thank you, everyone. Thanks.